Our new unit is on systems of linear equations. So the first lesson is going to be on developing a system of a linear equation. So a system of linear equations is essentially more than one linear equation, so more than one line. So when we're talking about this, the first things you're going to do when you're developing a system is decide what two variables you need and what they represent. So we're going to write let statements. We're going to create one equation that equals something from the problem and a second equation that equals something different from the problem. So we're going to use word problems to create systems of linear equations for right now. So the first one here, when we're doing this, as we're reading, I want you to use two different colors to underline or highlight the different parts of the question that belong to different equations. So tickets are sold for a school play. Felix buys 3 adult tickets and 2 student tickets. He pays $31. Ellen buys 1 adult and 1 student. She pays $12. So we have two different equations going on here. So the first one here is the 3 adult tickets, the 2 student tickets, and the $31. Those all go together. The second one is 1, and $12. So those go together. Now we're going to have to write let statements. So when we write let statements, we're talking about letting something equal something different. So I always like to use let statements where the variables represent something in the problem. So in this case, I'm going to say let A equal the adult tickets, and we're going to say S equals student tickets. A student ticket. So now that we have those two things, we can write our two equations. So because we have two different equations, we're going to have two different lines. So when we're doing this here, I'm going to go 3 adult tickets, so 3 times A, plus 2 student tickets, so 2 times S, is going to equal $31. Our second equation is going to be from the second part, so the green part, and it says 1 adult ticket plus 1 student ticket was equal to $12. This here is what we would call a system of linear equations. It's two equations that are representative of the same thing, but aren't exactly the same. So B here says we have an 8-passenger van, and 6-passenger vans carry 110 people. There are 15 vans in all. So when I'm underlining this, I have 8-passenger vans, 6-passenger vans, and now I have two different things going on here. I have 110 people, and I have 15 vans in all. So my 8 and my 6 are going with both, essentially. So I'm going to make my let statements first. So we're going to say let E equal the 8-passenger vans, and we're going to let S equal the 6. The 6-passenger vans. Now I'm told there's 8-passenger vans, 6-passenger vans, and there's 15 vans in all. So that's telling me that I have, if I take all the 8s plus all the 6s, I'm going to get 15. Now, here comes a little bit of a trickier part. There's 110 people, so I have 8 people per 8-passenger van, plus 6 people per 6-passenger van, and there's 110 people in total. So what I had to do is I took the E and the S, and I multiplied them by how many people would be in each van to equal how many total people there would be. So these two together create what we would call our system of linear equations. Part C, a gardener bought carrot seeds for $2 a package, squash seeds for $5, spent $38, and bought 13 packages. So my two different pieces here, the green is going to represent things that go for 1. So the first one, 2 packages, $5 a package for $38. And then I have 13 packages in total. So those are my two things that I need. So I'm going to have a let statement where I'm going to say C is equal to carrots, S is equal to squash, and I know that if I took my amount of carrots plus the amount of squash ones I bought, I'm going to get 13 packages total. Now what I'm going to do is I'm going to see how much money did I spend in total. Well, I know I spent $38. So carrots are $2 a package, so 2 times C, plus the $5 per package for squash times the number of squash packets is going to equal $38. A school sold 175 smoothies to raise money for charity. Banana smoothies cost. So 175 smoothies in total. $3, $5, and $625. So a banana costs $3, peach and mango costs $5. So let's make our let statement. I have B is equal to banana. And I'm going to say P is equal to the peach mango. Now that I have that, I'm going to write my two equations. So there's 175 in total. So if I take the amount of banana ones with the amount of peach ones and set it equal to 170, that's going to equal 175 smoothies, because however many I bought in total, doesn't matter how many of each one, add them together, I made 175. Now we're dealing with the money portion of it. So we need to know how much does a banana smoothie cost. So a banana smoothie costs me $3, so 3 times a banana one, plus the $5 for a peach mango one. And in total, I made $625. So this will tell you how many you sub in, how many of each, multiply them, add them, you should get 625. Total number of wheels on a bicycle and tricycles in the store is 45. So this here is the total number of wheels on both is 45. So we know there are 10 more bicycles than tricycles. That's what we need to know. My let statements are going to be B is for my bicycle. If I could spell. And T is going to equal my tricycles. Now I have a total number of wheels of 45. So a bicycle has 2 wheels plus a tricycle that has 3 wheels is going to equal a total of 45 wheels. Now when we're doing the rest of this here, I'm being told that I have 10 more bicycles than tricycles. So the amount of bicycles I get is going to be equal to the amount of tricycles plus 10. These two here would be my two equations for this linear system. Next example here says Dalton has $5 and $10 bills in his wallet. He has 12 bills in total with a value of $75. So here we go. We have $5 and $10 bills. There are 12 bills in total, and he has $75. So I'm going to say T is equal to my $10 bills, and F is equal to my $5 bills. You must write your let statements defining your variables every single time. So now I know that if I took the number of $10 bills, added the number of $5 bills to it, I would have 12 bills in total. I also know that if I was to take and go 10 times the $10 bills plus 5 times the $5 bills, I would get a total of $75. So an art gallery has a collection of 85 Northwest Coast masks of people and animals. So there are 85 masks in total. 60% of the people masks and 40% of the animal masks are yellow. There are 38 yellow masks altogether. So this here goes together. So now I'm going to have my let statement, and I'm going to say A is equal to animal, and P is going to equal the people masks. Now, if I took A, the animal masks, added the people masks to it, I'm going to get 85 total masks. If I go through, and when we're dealing with decimals, we can change them, so, or percentage, we want to change them into decimals, so 60% is equal to 0.6, so we just divided it by 100, and 40% is equal to 0.4. So all we did was we just divided 40 and 60 by 100 to turn it to a decimal, because we can't put percentages in for our equations. Now what I can do is I can now write an equation. So 60% of people masks, so 0.6 times P, plus 40% of animal mass, so 0.4 times A, was going to equal 38 yellow masks altogether. When we have a system of linear equations, the way that you can check your solution to make sure it's correct is by substituting your variables into both equations and check if they satisfy both equations. So for the next example here, we're going to say example 2 says a store display had packages of 8 batteries and 4 batteries. The total number of batteries is 320. So what we're going to do is we're first going to identify our variables. We're going to write our equations, and then we're going to check our solutions. So first steps first, let's read through this. They had 8-pack batteries and 4-pack batteries. Total number of batteries was 320. There were 1.5 times as many packages of 4 than 8. So those are the two things we need to know to write our equation. So I'm going to say E is equal to the 8 package, F is equal to the 4 packs. And now I can go through and I can say if I have 8 package batteries plus 4 package batteries, I'm going to, I have 8 batteries per 8 package plus 4 batteries times each 4 package is going to give me a total of 320 batteries in total. So I had 320 in total. So there are 8 per E package, 4 per F package, for a total of 320. Now, I'm going to go through and make my second equation, and 1.5 times as many 4-pack batteries as 8-pack batteries. So I have 1.5 times as many 4-package as I do 8-package batteries. So E is going to equal 1.5 times F. So now we can check if the solution satisfies the equation. So 30 packages of 8 and 20 packages of 4. So I'm now going to go with 8 times 30 plus 20 times 4, or 4 times 20, I should write it, I guess, sorry. 4 times 20. And this should equal 320 because that's what it's telling me I'm equaling. So this is going to equal 240 plus 80. And 240 plus 80 is 320. So 320 equals 320. This here is a true statement. This is definitely a true thing. So I can say, since this is true, these are equal, it satisfies that set of the equation. Now we're going to have to see if it satisfies the second equation, because it needs to satisfy both to be true. So now I have 1.5 times 20, because there were 20 batteries for the F, is equal to E, which was 30. So now that I have 1.5 times 20 equals 30, I'm going to say 30 is equal to 30. This is a true statement. Therefore, this is a system of linear equations because it satisfies both equations.